Air suspension is a type of vehicle suspension powered by an electric or engine-driven air pump or compressor. This compressor pumps the air into a flexible bellows, usually made from textile-reinforced rubber. The air pressure inflates the bellows, and raises the chassis from the axle. Overview. Air suspension is used in place of conventional steel springs in passenger cars, and in heavy vehicle applications such as buses and trucks. It is broadly used on semi-trailers, trains. One application was on EMT's experimental aerotrain. The purpose of air suspension is to provide a smooth, constant ride quality, but in some cases is used for sports suspension. Modern electronically controlled systems in automobiles and light trucks almost always feature self-leveling along with raising and lowering functions. Although traditionally called airbags or air bellows, the correct term is air spring. History. In 1901 an American, William W. Humphreys, patented an idea, a pneumatic spring for vehicles. The design consisted of a left and right air spring longitudinally channeled nearly the length of the vehicle. The channels were concave to receive two long pneumatic cushions. Each one was closed at one end and provided with an air valve at the other end. From 1920, Frenchman Georges Messier provided aftermarket pneumatic suspension systems. His own 1922-1930 Messier automobiles featured a suspension to hold the car aloft on 4 gas bubbles. During World War II, the U.S. developed the air suspension for heavy aircraft in order to save weight with compact construction. Air systems were also used in heavy trucks and aircraft to attain self-leveling suspension. With adjustable air pressure, the axle height was independent of vehicle load. In 1946, American William Bushnell Stout built a non-production prototype Stout Scarab that featured numerous innovations, including a 4-wheel independent air suspension system. In 1954, Frenchman Paul Margaux developed a functioning air-oil hydro-pneumatic suspension, incorporating the advantages of earlier air suspension concepts. Citroën replaced the conventional steel springs on the rear axle of their top-of-range model, the Traction Avant 15 Hydraulique. In 1955, the Citroën DS incorporated 4-wheel hydro-pneumatic suspension. This combined a very soft, comfortable suspension, with controlled movements, for sharp handling, together with a self-leveling suspension. In the U.S., General Motors built on its World War II experience with air suspension for trucks and airplanes. It introduced air suspension as standard equipment on the new 1957 Cadillac Eldorado Brougham. An air dome assembly at each wheel included sensors to compensate for uneven road surfaces and to automatically maintain the car's height. For 1958 and 1959, the system continued on the Eldorado Brougham, and was offered as an extra cost option on other Cadillacs. In 1958, Buick introduced an optional air-poised suspension with 4 cylinders of air for automatic leveling, as well as a bootstrap control on the dashboard to raise the car 5.5 inches for use on steep ramps or rutted country roads, as well as for facilitating tire changes or to clean the white wall tires. For 1959, Buick offered an optional air ride system on all models that combined soft-rate steel coil springs in the front with air springs in the rear. An optional air suspension system was available on the 1958 and 1959 Rambler Ambassadors, as well as on all American Motors cross-country station wagon models. The air coil ride utilized an engine-driven compressor, reservoir, airbags within the coil springs, and a ride height control, but the $99 optional system was not popular among buyers and American Motors discontinued it for 1960. Only Cadillac continued to offer air suspension through the 1960 model year, where it was standard equipment on the Eldorado Seville, Biarritz, and Brougham. In 1960, the Borgward P100 was the first German car with self-leveling air suspension. In 1962, the Mercedes-Benz W112 platform featured an air suspension on the 300 SE models. The system used a Bosch main valve with 2 axle valves on the front and 1 on the rear. These controlled a cone-shaped air spring on each wheel axle. the system maintained a constant ride height utilizing an air reservoir that was filled by a single-cylinder air compressor powered by the engine. In 1964, the Mercedes-Benz 600 used larger air springs and the compressed air system also powered the brake servo. Rolls-Royce incorporated self-leveling suspension on the 1965 Rolls-Royce Silver Shadow, a system built under license from Citroën. In 1975, the Mercedes-Benz 450 SEL 6.9 incorporated a hydro-pneumatic suspension because the patents on the technology had expired. This design replaced the expensive, complex, and problematic compressed air system that was still used on the 600 models until 1984. Air suspension was not included in standard production American-built cars between 1960 and 1983. In 1984, Ford Motor Company incorporated a new design as a feature on the Lincoln Continental Mark VII. In 1986, Toyota Soro introduced the first electronically controlled, a semi-active full air suspension. Modern automobiles, vehicles that use air suspension today include models from Maybach, Rolls-Royce, Lexus, Jeep, Ram, Cadillac, Mercedes-Benz, Porsche, Land Rover, Range Rover, Ssangyong, Audi, Subaru, Volkswagen, Lincoln, Ford, and Tesla, among others. Citroën now feature hydroactive suspension, a computer-controlled version of their hydro-pneumatic system, which features sport and comfort modes, lowers the height of the car at high speeds and continues to maintain ride height when the engine is not running. The air suspension designs from Land Rover, Ssangyong, Chrysler, Subaru, Audi, Volkswagen, Tesla, Porsche, and Lexus models feature height-adjustable suspension controlled by the driver, suitable for making it easier to enter the vehicle, clear bumps, or clear rough terrain. The Lincoln Continental and Mark VIII also featured an air suspension system in which the driver could choose how sporty or comfortable they wanted the suspension to feel. Porsche has taken this to the next level on the Panamera with a system that changes the spring rate and damping settings, among other changes, for their sport track modes. The Mark VIII suspension settings were also linked to the memory seat system, meaning that the car would automatically adjust the suspension to individual drivers. The control system in the Mark VIII lowered the suspension by about 25 mm at speeds exceeding about 100 km per hour for improved aerodynamic performance. One-way automakers strive to improve gas mileages by utilizing active suspension technology. Tesla Motors offers an optional active air suspension on the Model S to lower the vehicle for aerodynamics and increased range. Custom applications. Over the last decade or so, air suspension has become popular in the custom automobile culture. Street rods, trucks, cars, and even motorcycles may have air springs. They are used in these applications to provide an adjustable suspension which allows vehicles to sit extremely low, yet be able to rise to a level high enough to maneuver over obstacles and inconsistencies on paved surfaces. These systems generally employ small, electric or engine-driven air compressors which sometimes fill an onboard air receiver tank which stores compressed air for use in the future without delay. High-pressured industrial gas bottles are sometimes used in more radical air suspension setups. Either of these reservoir systems may be fully adjustable, being able to adjust each wheel's air pressure individually. This allows the user to tilt the vehicle side to side, front to back, in some instances hit a three-wheel, or even hop the entire vehicle into the air. When a pressure reservoir is present, the flow of air or gas is commonly controlled with pneumatic solenoid valves. This allows the user to make adjustments by simply pressing a momentary contact electric button or switch. The installation and configuration of these systems varies for different makes and models, but the underlying principle remains the same. The metal spring is removed, and an airbag, also referred to as an air spring, is inserted or fabricated to fit in the place of the factory spring. When air pressure is supplied to the airbag, the suspension can be adjusted either up or down. For vehicles with leaf spring suspension such as pickup trucks, the leaf spring is sometimes eliminated and replaced with a multiple bar linkage. These bars are typically in a trailing arm configuration and the air spring may be situated vertically between a link bar or the axle housing and a point on the vehicle's frame. In other cases, the airbag is situated on the opposite side of the axle from the main link bars on an additional cantilever member. If the main linkage bars are oriented parallel to the longitudinal axis of the car, the axle housing may be constrained laterally with either a panned rod or Watts linkage. In some cases, two of the link bars may be combined into a triangular shape which effectively constrains the vehicle's axle laterally. Often, owners may desire to lower their vehicle to such an extent that they must cut away portions of the frame for more clearance. A reinforcement member commonly referred to as a C-notch is then bolted or welded to the vehicle frame in order to maintain structural integrity. Specifically on pickup trucks, this process is termed notching, because a portion of the cargo bed may also be removed, along with the wheel wells, to provide maximum axle clearance. For some, it is desirable to have the vehicle so low that the frame rests on the ground when the airbags are fully deflated. Owners generally choose between having their cars tuck their wheels into the arches when their air suspension is fully lowered, or alternatively they can choose to go for fitment, which in partnership with stretch tires sees the arch itself fit in between the tire and rim. Air suspension is also a common suspension upgrade for those who tow or haul heavy loads with their pickup truck, SUV, van or car. Air springs, also called air helper springs, are placed on existing suspension components on the rear or front of the vehicle in order to increase the load capacity. One of the advantages of using air suspension as a load support enhancement is the air springs can be deflated when not towing or hauling, and therefore maintaining the factory ride quality. Common air suspension problems. Airbag or air strut failure is usually caused by wet rust, due to old age, or moisture within the air system that damages it from the inside. Air ride suspension parts may fail because rubber dries out. Punctures to the airbag may be caused from debris on the road. With custom applications, improper installation may cause the airbags to rub against the vehicle's frame or other surrounding parts, damaging it. The overextension of an air spring which is not sufficiently constrained by other suspension components, such as a shock absorber, may also lead to the premature failure of an air spring through the tearing of the flexible layers. Failure of an air spring may also result in complete immobilization of the vehicle, since the vehicle will rub against the ground or be too high to move. However, most modern automotive systems have overcome many of these problems. Airline failure is a failure of the tubing which connects the airbags or struts to the rest of the air system, and is typically DOT-approved nylon air brake line. This usually occurs when the air lines, which must be routed to the airbags through the chassis of the vehicle, rub against a sharp edge of a chassis member or a moving suspension component, causing a hole to form. This mode of failure will typically take some time to occur after the initial installation of the system, as the integrity of a section of airline is compromised to the point of failure due to the rubbing and resultant abrasion of the material. An airline failure may also occur if a piece of road debris hits an airline and punctures or tears it, although this is unlikely to occur in normal road use. It does occur in harsh off-road conditions, but it's still not common if correctly installed. Air fitting failure usually occurs when they are first fitted or very rarely in use. Cheap low-quality components tend to be very unreliable. Air fittings are used to connect components such as bags, valves, and solenoids to the airline that transfers the air. They are screwed into the component and for the most part push-in or push-to-fit DOT line is then inserted into the fitting. Compressor failure is primarily due to leaking air springs or air struts. The compressor will burn out trying to maintain the correct air pressure in a leaking air system. Compressor burnout may also be caused by moisture from within the air system coming into contact with its electronic parts. This is far more likely to occur with low-specification compressors with insufficient duty cycle, which are often purchased due to low cost. For redundancy in the system, two compressors are often a better option. In dryer failure, the dryer, which functions to remove moisture from the air system, eventually becomes saturated and unable to perform that function. This causes moisture to build up in the system and can result in damaged air springs and/or a burned-out compressor. Use on coaches and buses. Most factory-standard coaches have a system called ferry lift. This allows the air suspension to be raised above the normal ride height level to originally aid loading and unloading the vehicle on and off ferries due to their steep ramps and risk of grounding out, but can be used on rough ground or on steep crests. Although the ferry lift may be installed on some buses, the kneel-down facility is more common on public transport buses. This allows air to be released from the suspension system to decrease the step that passengers have to climb to enter the bus, as they usually level out to curb level. The kneel-down facility is also used when using the built-in wheelchair ramps. See also. References. External links: Air suspension terms and definitions arniting.com. Air suspension FAQs and terminology airliftperformance.com. Air suspension terminology airliftcompany.com.